So we began Module 2 today, linear and exponential functions, and we did piggies and pools today, which we probably didn't get through, and you're going to be finishing. So I want to go through some important terms that are really going to lay the foundation of what we're going to be covering. So discrete and continuous, we began today, and these are probably new terms that we're not very comfortable with. So I wanted to give you a bit more information on it. Discrete is something that is, and the easiest way to think about it, are items that are counted. Okay, so they are counted items. And I mean by that we have specific values. So, an example, and the examples are where you're really going to start to get clarification in this. An example of a discrete function would be people. You cannot have part of a person. So I would have one person, two people, three people, four people. What it means to be discrete is the numbers between those are not solutions. They are not answers. They cannot exist for a discrete function. So 1.2 people, it's not possible. Okay, it's either 1 or 2. You cannot have the values between. So that is what a discrete function is. So people, right? Animals, tickets. No one's going to buy part of a ticket to a concert or to a movie. So they're going to be things that have specific values. I can't have any number for it. There are only certain numbers that this will work for. When we graph in a discrete function, what we have to remember, and I'm just sketching a graph, this is not anything in particular. Okay, I'm just going to do my first quadrant. When I have a discrete function, they are going to be points, and we do not connect them when it is a discrete function. The reason being, when you connect the points, what you're telling me is everything on that line is a solution. Okay, and we just said that you can only have certain answers. So we will not connect our points in a discrete function. Well, the other function is continuous. All right, and a continuous function is an easy way, anything that's measured is a continuous function. All right, and continuous functions can have any value. So if we think about some examples of that, it would be height, rate, weight, okay? So if we think about those are all measured items. Height, everyone in this class, you're not either 5 foot or 6 foot or 4 foot. You have everything in between it. You have inches. You have half an inch, all right? Usually the shorter a person is, they're like, I am 4 foot 10 and 3/4, okay? So when you are going to have any value that works for it, all right? 120 pounds, 120.2 pounds, okay? That is a continuous function. And that's what you've been used to graphing. A continuous function is going to be graphed. So we go, and again, we've got our points, okay? But in this case, we go ahead and connect those points. What causes some students issues, they think continuous as in it goes on forever. That is continuous, but it's not what we're using in this terms. That's a synonym, okay? So you're right, I can continue counting people, all right? And that's where some students get confused. They're like, well, I can keep going. Yes, but in this terms, discrete means I can only have whole people. I can only have specific items, specific values. Continuous means you can have any value. So everything in between these points is also a solution to this problem. So let's connect this back to what we did in the last section. we were covering sequences. All right, and this is something that we're going to be touching on. Discrete, all right, counted, specific values. Sequences are discrete functions. The reason being, as we said, when we do a sequence, it's a pattern. So 2, 4, 6, 8, an arithmetic sequence with a common difference of 2. In this, 3 is not part of the sequence, nor is 5, nor 5.1, or any values in between 2 and 4. So because sequences are particular numbers in a special order, they are going to be discrete functions. Okay, so when we've been graphing so far, we have not been separating the points, and that's because we had not learned about discrete versus continuous yet. So from now on, when we are graphing our discrete sequence, we want to remember to not connect the points for it. So 2 more terms, and these should be familiar to us, that we want to talk about are domain and range. Okay, domain and range are talking about our graph and identifying values. So your domain is the set of all possible input. Okay, remember, input are your x values.
Please pardon the interruption. Ms. Spiegel, please call the front office. Ms. Spiegel.
Sorry about that. All right, so your domain is the set of all possible input values. All right, we said input is your x. That's your independent variable. Okay, your range, as I'm sure you have guessed, is the set of all possible output values, which are your y values. So what we're going to be doing at times is identifying the domain and range for a function. And understanding when you have discrete and continuous is important because the way we are going to write domain and range will vary based off if it's discrete or continuous. All right, because if it's continuous, I can say, all right, well, it's all values from 7 to 24, everything in between there. But that's not going to work when I have a discrete function because, as we said, it's only particular values. So we're going to be looking at how to do that on Thursday. All right, so we will be covering that on Thursday more so. So right now we want to be comfortable with knowing discrete versus continuous. And that's what you have a couple homework problems on tonight, is reading scenarios and being able to identify whether or not we have a discrete or a continuous function. So the easiest way, always think about it, can I have part of something? Okay, can I have part of a person? And every year I always get students who are like, well, maybe they had their leg amputated. No, they are still a full person, okay? So don't overthink it. We try to think about some of these problems too much, and then we end up second guessing ourselves. So again, remember, discrete are counted items. All right, I am going to buy a t-shirt, okay? I can buy 2 t-shirts. You cannot buy 1.7 t-shirts, all right? I can, buy a car. I'm not going to buy part of a car, all right? So discrete are counted, specific values. Remember, sequences are going to be a discrete function. Continuous are measured, any value, which is why I can connect the points, because everything in between those points is also a solution. All right, so complete those few homework problems. We don't have any synchronous class tomorrow. You have to finish the Desmos activity if you haven't done that or didn't get through it all in class. And I will see you on Thursday. Have a good day.